Hello everyone, we will discuss about how to solve the LP problem. In this I am using Big M method. This is the problem that had given, so we should change it in standard form first. After that, because of the LP problem is to minimize Z, then add negative MA1 and negative MA2 to the objective function. A1 and A2 is artificial variable 1 and artificial variable 2. So we should insert this in initial tableau. To eliminate artificial 1 and artificial 2 from row 0, simply we should replace row 0 by new. So this is the new row 0. After we get the new row 0, we should update it in the initial tableau. The next step, we should find the most negative coefficient, which will be the entering variable. In this case, negative 10m minus 4 is the most negative coefficient. So x1 will be the entering variable. And then we need to find the ratio of the BV. Ratio of the basic variable is 150 and 37.5. So the lowest ratio will be the leaving variable. In this case, artificial 2 is the lowest variable. By the way, now we should make the coefficient to 1 and others to 0. So we should make ERO and solve the problem. So this is the result that we will get. We should make sure that row 0 coefficient should be positive, but here we do have negative coefficient, so must proceed with the same step as shown before this, as we select most negative coefficient which represent entering variable and smallest ratio as leaving variable. So in this x3 is the most negative coefficient which will be the entering variable, and artificial 1 is the smallest ratio which will be the leaving variable. So same goes to table 2. In this, x4 will be the entering variable and x1 will be the leaving variable. After the ERO, we got the answer for table 3. All variable in row 0 is non-negative. Therefore, it is optimal tableau. And all NBV non-basic variable have no zero coefficient in row 0. Thus, it is unique optimal tableau. As optimal solution, we got Z equals to 400. The next, I am going to explain how to solve dual LP problem. So this is the main criteria that we should know about dual LP problem. If in primal number of variable is equals to number of constraint in dual, number of constraint equals to number of variables, coefficient of objective function equals to coefficients of our right hand side, coefficient of right hand side is equals to coefficient of objective function, coefficient of variable equals to coefficients of constraints. So I am going to explain. In this question, we have primal dual criteria. So Z will be representative as W. So this is the main thing, and there will be minimum W. Coefficient of objective function will get from the right hand side of the primal. For the dual, the coefficient of objective function will get from right hand side of the primal, and then the coefficient of constraint will get from the first variable of primal. For the right hand side of the dual, constraint will get from the coefficient of the objective function of primal. The equality signs will be represented from the variable in primal. Sign of variable in dual will be from the constraint equality in primal. So the equal sign will be as URS, which means unrestricted sign. As last, C is find the dual solution for each of the LP based on their optimal tableau. The optimal tableau will get from the A, which we have done. So the optimal tableau will be this. Here, to find the dual solution, we should refer to the table that had given, which means equal is coefficient of A which is equal the coefficient of artificial one minus M. So this is the criteria we are going to use here because we have equal. So for the Y1 we will get 5/9 plus M, 5/9 plus M minus M as the table that have given. So the answer should be 5/9. And then as Y1, same as the table, so coefficient of A1 minus M, which represent 7/9 plus M minus M. So we will get 7/9.
Okay, so today I'm going to show the tutorial on how to solve LP problems by using linear program solver. So this is our equation. Okay, first go to File and then click New and then click Table Model. So this table will be pop up and then fill in the number of variable, number of constraints, and number of objective remain 1. And then after that, choose whether the problem is a maximization problem or minimization problem and then click OK. After that, this table will be pop up and then insert the coefficient of the variable in the table. So it will be like this. Click the green solve button and the output of the result will be shown. So this is the output of the result.